Then we have the lincomycins. So lincomycins, they have this striking structure or component, the sulfur, and they are also considered as antibiotics. They are derived from Streptomyces lincolensis. That is why it is called as lincomycin. So lincomycin is the most active and medicinally and medically useful among the different compounds obtained from fermentation. So its structure is 7-chloro-7-deoxy, and this is the derivative of the clindamycin, which is very useful in the management of soft skin tissue infection. So lincomycins resemble macrolides in antibacterial spectrum and biochemical mechanism of action. So they are considered as bacteriostatic, and they act on the protein synthesis 50S ribosome. So its action may be bacteriostatic, as I've mentioned a while ago, but sometimes lincomycin can be bactericidal depending on the concentration. So the same also with our aminoglycoside, it acts on protein synthesis, but if you would increase concentration, they both can behave as bactericidal. So this is what our lincomycin looks like. It has sulfur here. So this is the original structure of lincomycin, and this is our clindamycin. So it has addition of our chlorine here, making it called as clindamycin. Furthermore, we have another group of antibacterial called polypeptides. So powerful bactericidal antibiotics are polypeptides, and they are derived from Bacillus species. That is why they are also called antibacterial antibiotics. But they have limitations because of their lack of systemic activity. Now, specifically, its mechanism of action, they interfere with bacterial cell wall synthesis and are effective only against gram-positive. So examples of our polypeptides, we have vancomycin, teicoplanin, and bacitracin. Okay? So polymyxins, we have colistin, which is very important to take note that this is restricted drug. Okay? Colistimethate and gramicidin. Okay, so these are under our polymyxin disulfates. And this one is for vancomycin. So I'm just presenting this because they don't have specific structures. That's why they are just termed as polypeptides. Wala silang specific structure resembling each other's example, but they have polypeptides in their structures. Yeah. Just like this one. Okay? Polypeptides. Makita nyo? Itong mga chains dito, these are peptides. Yan. Peptide links. So, vancomycin is an example of polypeptides. So, this is the point for modification of vancomycin. Okay, so we can have peripheral modification that increases potency on this part and provides second MOA, which is on reductive amination. Okay, this one. So if this is added, our vancomycin, aside from inhibiting the protein synthesis, it can also inhibit transglycosylase and cell wall biosynthesis. So it became more stronger. Then here in the X part, it's a binding pocket modification. From oxygen, we can change it to sulfur, to amino or hydrogen, and it is designed for certain binding of compounds. And then here, we can do N-methylation here, or you can add methyl group here in our COOH. That would help cell membrane permeability. So that would help with this very bulky structure and enhance cell membrane permeability to penetrate the bacterial cell wall. Now, the other one is another polypeptide. So, marami lang siyang peptide, but it does not resemble vancomycin. This is our bacitracin. So, stability is affected by pH and temperature. Slightly acidic or neutral solutions can be stable as long as 1 year. And zinc enhances activity of bacitracin and enhances water solubility. So it is available in the form of IV and topical solution. And then another one is the polymyxin B. Marami pa rin siyang peptides. So it's difficult to memorize this, the polypeptides. But if ever you have to make it parang familiarize more, remember the structure of vancomycin. And then we have what we call as unclassified antibiotics because they have no resemblance talaga with other type of antibiotics. It's better for vancomycin and bacitracin and polymyxins because they have this constant peptide links. But for chloramphenicol, mupirocin, and linezolid, they are unclassified. So this is the stereochemistry of chloramphenicol. Yeah. So replacement of phenyl group by other aromatic systems or cyclic systems such as cyclohexyl, furyl, naphthyl, pyridyl, thioneal results in loss of activity. So maybe you will not just add anything or replace anything in the phenyl group. So wag na lang dagdagan. And then replacement of nitro nitro by amino, hydroxyl, sulfur, and cyanide results in loss of activity pa rin. So do not change anymore or do not replace anymore the amino part. Then shifting of the nitro part. Saan ba yung nitro part? Here. The nitro part. Huwag na lang dagdagan ang nitro part, tsaka huwag na ding dagdagan ang phenyl part. This one will lose activity. And then shifting of nitro from para position leads to loss of activity pa rin. So, wag ding galawin ang positioning. The propane diol moiety should be in the levothioisomer to make it active. And then replacement of hydroxyl and extension or suppression of terminal methyl alcohol, methanol abolishes activity. So in other words, you will not just add anything at all to make it constantly to retain its minimum antibacterial property. And then another one, replacement of nitro group by electron withdrawing group gives active compound. So this is what you have to take note. You can add you can replace nitro compounds with EWG, such as our CH3CO2 and CH3CO in the case of thiomphenicol and cetophenicol. Now, our bacteria also develop resistance against our chloramphenicol. So bacterial resistance to chloramphenicol arises from the ability of certain strains of bacteria to produce an enzyme pa rin that can acetylate hydroxyl at C1 and C3 of the propanol moiety to produce 1 acetoxy and 3 acetoxy derivatives. This is our enzyme chloramphenicol acyltransferase. So this is the resistance, the mechanism resistance of our bacteria against chloramphenicol. And then the next unclassified is the linezolid. So the linezolid is used for vancomycin-resistant microorganisms. And as the same way for colistin, it is highly restricted antibacterial. So this is the structure of our linezolid. It has 4 chunks. The first one, the pink one, the morpholino group, enhances pharmacokinetic profile. This one, morpholino group, enhances pharmacokinetic profile and improves water solubility. The next one is in the blue one. This is the difluoro compound that has been found to be promising. So it should have S configuration. This one, fluorophenyl moieties is optimally in 50S. This one are our fluorine. They're the ones who directly in contact with our ribosomal unit. And then the N-aryl group, this one, and this will allow treatment of our antimicrobial property. The fourth one is our alkyl groups. Okay, we have here our carbonyl, and then we have here our methyl, and then our amino. So we should not replace it with heterocyclic ring with large substituents because it can lose activity. This is linezolid. And then the other one is mupirocin. Available on topical form in IV or oral administration of your mupirocin is not viable because it's rapidly metabolized. So the principal metabolite of our mupirocin, if when it's inactivated in the body, if you ingest it orally, it will become monic acid. And monic acid has no antibacterial activity. That is why our mupirocin, which is now the Bactroban, is available in topical ointment. Okay, so that would be all for our antibacterial antibiotics. Thank you.